This is build up your understanding, question number 15 of magnetic effect of current, Pathfinder book. So let us now see, it's a very good question, advanced level question, and very, very highly probable for JEE advanced. So let us see the question. So question is, there is an arrangement. So this arrangement you can see, this is the arrangement, or you can refer to this diagram also. There is a parallel plate capacitor, distance between them is D, and there's a potential difference, V is applied. Electrons are emitted from the negative plate with negligible initial velocity. So this is positive plate and this is negative plate. Electrons are emitted from here, right? So you can see one dot here. Now these electrons are attracted towards the positive plate, definitely, since electric field is in this direction, force on electron will be in upward direction. So this is the direction of force on electron, opposite to electric field. And thus creating a very small current. Of course, when electrons will move, direction opposite to the electron movement is the direction of current. And then current is registered by the micro-ammeter. So this is the micro-ammeter. Now question is, what minimum magnetic field must be applied perpendicular to the electric field in the capacitor so that micro-ammeter registers no current, and denote charge and mass of the electron by E and M respectively, and we don't have to consider gravity. So let us see the analysis. Electric field inside is V by D, right? V equal to ED formula. Now we can, since it is starting with negligible velocity, we can apply the magnetic field in downward direction. So we can apply the magnetic field like this. If you apply the magnetic field like this, then what happens? It is electric field and magnetic field, both are perpendicular to each other, and it is going to move in a cycloid path. So the cycloid path is going to be like this, right? So you want, there should not be, you want no current in micro-ammeter. That means you want this electron to move like this. You want it to just miss the upper plate. Fine. So that condition we are going to use. So for that, now magnetic field should be applied in downward direction. You can use left hand rule and see, since magnetic field is into the plane, and then velocity after a few seconds, velocity will be in this direction because initially the velocity is 0, so magnetic force will be 0. But due to the influence of electric force, it will acquire certain velocity in upward direction, and then magnetic force will also be, now magnetic force you can use left hand rule. So magnetic force will be in this direction, right? So magnetic force is in this direction, which is plus x direction, its velocity will start, it will start gaining velocity in x direction also. So that is how it moves in cycloid path like this. Fine. So for cycloid path, now if you have to solve it from differential equations, it's very long. So I will use another method, that is the Lorentz transformation. From that, you can solve it just in one line. So if I use Lorentz transformation, so the idea here is that the electric field right now, electron is subjected to electric and magnetic field both. So from using Lorentz transformation, we will remove electric field, or we will start moving such that there is an electric field which is in opposite direction of this E, and then this question becomes purely, and then this electron comes under the only magnetic field, right? So this is the Lorentz transformation. If you have not studied this, you can study from the theory book of Rudolph, electromagnetism. So if suppose there is an observer moving with a velocity V, then electric field for that observer is E naught, original field, plus V cross B, right? So this is now the same plate I have drawn here. This is electric field downward, magnetic field is into the plane. Now you have to choose this is what you have to think, right? So here this E you want it to be 0. So this V cross B should be equal to minus E naught. E naught is this original field. Fine. So you have to then visualize that how should you, which observer you choose, right? You have to choose the observer so that the electric field generated is in this direction, and it exactly cancels its magnitude. So magnitude wise, it's fine, because if you put this as 0, then you can see the magnitude was, you can see 0 is equal to E naught minus VB, right? Only magnitude wise. So velocity, the observer velocity should be V by B. Fine. Then in what direction? See V cross B. Now you should move in this direction. So observer should be moving. I think I have written here. Yes. So observer should be moving in this direction. Then if observer is moving in this direction, then V cross V. So velocity is towards right, magnetic field is into the plane, use left hand rule, then V cross V direction will be upward. So if V cross V direction is upward, see here, then this will definitely cancel this original field if velocity magnitude is E by V, right? So with respect to this observer will not see any electric field. It will see only magnetic field. But the point is that with respect to observer, the electron will have velocity in this direction, right? Electron is at rest with respect to what. So this, with respect to this observer velocity will be given to this in opposite direction. So this is how electron will have initial velocity. Now you have only magnetic field, right? It's relief. You don't have electric field. It's very simple. Velocity and magnetic field both are perpendicular. It starts moving in circular path. And the radius of circle also, you know that R is equal to mv0 by qb, right? So when R is equal to mv0 by qb, then R should be equal to how much? This is D. So R should be equal to D by 2. And Q I have written as E here. And B is B only. V0 is, remember, what was V0? See here, top right corner, E by B. And E was V by D, which was given in the question itself. So those values, if you substitute, you get value of B as 2mv by root EB squared, right? So thank you very much for watching. And then if you ask me, it's an amazing question and it can come in JEE Advanced again as it is in 2022. Fine. So thank you. If you have liked my analysis, please like this video and subscribe this channel also. Share this channel with your friends. Thank you very much.